My name is Austin Kemp. I'm a MCDB student at the University of Colorado Boulder, and I'm going to be talking about the future uses of CRISPR-Cas technology. Background on CRISPR-Cas: it was originally found in E. coli bacteria as a way to defend itself against virus attacks. When a virus wants to attack an E. coli bacteria, it injects its own DNA into the E. coli bacteria to try to kill it. And this has been happening for so long that E. coli has a lot of these attacks logged in its genome. Every time it's attacked by a new virus, it takes note of that and puts it in its genome so it can better protect itself in the future from these attacks. The system, CRISPR-Cas, is used in E. coli to really efficiently and effectively prevent damage from viral bacteria. What happens is when a virus comes in and tries to inject its DNA, if the cell has seen that DNA before, it loads a chunk of an RNA that's analogous to that DNA that it's seeing coming in from the virus into the Cas protein, and that gives the Cas protein a target. The Cas protein goes up to the viral DNA that's trying to attack the cell, and with the target, it can chop in half the DNA to degrade it. Scientists can use this technology by coding the target that the Cas protein is meant to chop and injecting it into a cell that it wants to modify. Now, if you just chop the DNA that you want to modify in half, that will knock out the gene that you're trying to target, or you can cut it and through a different process insert a different piece of DNA that you want in that place. You can also replace genes too by cutting it in two sections, taking a gene out and putting another gene in. And it's a pretty new technology, but what we've seen is recently a scientist named He Jiankui has done this in humans. He claims that there are two baby girls born in China, Lulu and Nana, who don't have a CCR5 gene because he used CRISPR-Cas to knock that gene out in their embryos. The point of doing this was to make them immune to HIV. What HIV does is when it infects your cells, it modifies that CCR5 gene, and so he wanted to knock that gene out so that they were immune to the virus. The problem that we see in today's society is a lot of people are dying from cancer, from viruses, and a lot of people are affected by genetic disease, and also a lot of people are dying of old age. These are all problems that CRISPR-Cas can solve in the future. In theory, these can all be solved. In the future, CRISPR-Cas will be cheaper and faster and more precise. We've already seen gene editing become cheaper, faster, and more precise with CRISPR-Cas, but in the future it's going to be even easier to do, and with more research and with higher powered computers, we'll be able to map out all these genetic pathways in humans so that when we do an edit, it will be with 100% accuracy. We'll know exactly what's going to happen when we edit this gene. The benefits of using CRISPR-Cas heavily in the future is that we can essentially end disease. We can modify your immune system to be better at targeting cancer cells that won't regulate themselves. We can end viral disease. We can end genetic disease. In theory, we can make even eternal youth possible. We can, with the help of gene therapy and gene editing, we can prevent a lot of the problems that happen in old age. And We can make people live for thousands of years instead of 100 years. And then, of course, the one that everybody's talking about is designer babies. So when you edit an embryo, that gene becomes heritable. That edit becomes heritable, and it can be passed on from generation to generation. And so, by today's standards, we say, well, we shouldn't mess with anything but preventing really, really awful diseases. But as this process becomes more streamlined and it becomes more well accepted in society, it's inevitable that we'll start using it to create better muscular structure or height, or even superhuman traits like being super smart, or being better adapted for space travel, or even being able to breathe underwater. The bad sides of using this CRISPR-Cas technology in the future are it's going to create discrimination, because there will always be people that won't have access to gene editing, and there will always be people that will have access to gene editing, and that's going to create this crazy hierarchy and power structure, and inevitably the people on top are going to discriminate and oppress the people on bottom. And on top of that, if you were a totalitarian dictator who wanted to have better control over your citizens, all you'd have to do is genetically engineer an army of super soldiers to police your people, and that would be really bad. So, of course, there's benefits and drawbacks to using this technology in the future, but I think the take-home message here is that the benefits are so good of ending disease and making people live longer, and really taking the next step in human evolution, that we need to continue to research this process and also regulate it so that it's less likely that this technology can be used for bad, and maximize the benefits.